Okay, so we're gonna go over the answers for the problem set for lectures 1 and 2. So this is just for the playlist of the 2 lectures that I have uploaded, and we're gonna just go over the answers. There is or was a problem set. I am probably also gonna link it here, but I did link it in my last video for the lectures. So let's go over the problem set. So multiple choice, choose a molecular form of an element. So H2O, that is not the right answer. Iodine is molecular, iodine is the right answer. So let's circle that one, and HCl is not, because there is two different atoms, two different elements. H2O is also two different elements, and Cl minus, that is an element, but that's an ion, and it's not a molecule. Remember that a molecule is made up of, well, more than one atom, right? So molecular iodine, the answer is B. Molecular iodine is an element. So notice that the molecule is made up of two iodine atoms bonded together by one covalent bond, right? So like this. It's gonna look something like that, right? Since we have the same species of atom, this is still considered an element. And more specific, we'll actually call this a molecular element. So let's go ahead and do number 2. Select an element. Choose all that apply. You may use a periodic table. So I'm not going to use a periodic table, and we are going to basically choose an element, and I'm going to have more than one choice, right? So 100% gold ring. If we look back at the lecture, we went over something similar, and yeah, 100% gold ring would be considered element. 10% cotton and 90% polyester fabric, that's no. NaCl, remember from last question, we crossed it out because it's two different elements. It is not an element, a pure element. Silver, if you look at the periodic table, you will see silver in the periodic table, so that is an element. So the answers are A and D. We have a ring that is made up of 100% pure gold. This means that theoretically it is composed entirely of gold atoms, and therefore it is an element. The gold ring is an example of a macroscopic form of an element, with a gold atom being its fundamental building block, right? And silver, we already said we can find it in the periodic table of elements. So let's go ahead and do number 3. Amino acids contain an amine group, which is this, an amino group. How many atoms does the amine group have? Okay, so it is the one that's being circled. And this is an amino acid. So it's going to look something like this. So we have an N, right? And it's going to be bonded to 2 H atoms. And this is the lone pair. You don't have to know a lot about that yet. We're just, if you only know, if you're new to chemistry, you don't have to know a lot about lone pairs, but that's a lone pair, just an FYI. So amino acids, how many atoms does a amine group have? So atoms, we're looking for individual atoms. By the way, this is connected to a carbon. We're looking for individual atoms. So how many do we see here? Let's see. 1, 2, 3. 3 individual atoms. So is it 2? No. Is it 1? No. Is it 3? Yes. Is it none of the above? It's not. So the amino group is basically in the circle. It is composed of a nitrogen atom and 2 hydrogen atoms, a total of 3 atoms. So if the question were asking how many different elements the amine group has, then the answer will be 2, right? The nitrogen and hydrogen, but that is not what it is asking for. Let's go to number 4. If you guys have any, I'm trying to go as fast as possible. If you guys have any questions, please just let me know. Look at the amino acid phenylalanine in the previous question. How many bonds does each oxygen atom form? Okay, so in lecture we went over the organic structure, organic line structure, which will be what the phenylalanine will be of. So the question is asking how many bonds does each oxygen form, and let me rewrite the phenylalanine. And I'm going to rewrite it this way. Okay, so how many bonds does each oxygen atom form? Well, let's see. The amino group. By the way, the dark wedge, means that the amino group is actually pointing towards you, so it's pointing out of the page. So that's what it means. And that's just an FYI again, not that important for this problem. Okay, how many bonds does each oxygen atom form? Well, let's see. Let's go ahead and change the color to red. An oxygen atom is here. An oxygen atom is there. How many bonds do they form? Let's see. This one has 1. This one has 2. This one has 1. This one has 2. So is it 2, 1? No. Is it 1, 2? No. Is it 2? Yes. Is it 4? No. So remember, oxygen typically likes to form 2 bonds. If you look at the top oxygen, it is forming a double bond with a carbon atom. This is going to be the carbon atom. Remember our discussion on organic line structure in lecture? So remember that. And then look at the oxygen bonded to a hydrogen atom, which is this one, right? It is bonded to a hydrogen, and it is also bonded to a carbon, which is this one. So it is 2 bonds. So each of them form 2 bonds. Okay, let's go on to number 5. Assume we have an energy ray that can cleave atoms in half. If we cleave a gold atom in half, we get 2 gold atoms that form a gold molecule. Is that true? No, that is not true. That is false. So remember, a gold atom is an element and cannot be broken down any further, and that goes for elements and still remain. So it cannot be broken down any further and still remain with the same properties that make it gold. An element, so an element cannot be broken down any further and still remain the same, right? So that answer is false. Let's go to number 6. Okay, so each ball represents an atom. What best describes this drawing? Is it heat? It's not heat. Heat does not have atoms, right? The heat is energy. It's a type of energy. Light from a nightlight. Light is made out of photons. Remember, I think I said that in the lecture. I don't remember too well. But light is made of photons. It does not have atoms. Thermal energy. Again, thermal energy is another type of energy, right? A piece of matter. Yes. So the other options do not consist of atoms, but matter, remember in lecture, matter does consist of atoms. Let's go to number 7. This is ozone, right? What option best describes ozone? And a hint is that we're going to ignore the charges. So let's ignore the charges. Just ignore them. Pretend they're not there, right? Is it a molecular element? Well, let's see. That's one type of atom. One type of atom. Another type of atom. More than 2, so like basically 2 atoms or more bonded together is a molecule. And like look at like we did in number 1, I believe. This is an oxygen bonded to another oxygen, bonded to another oxygen, ignoring the charges. And they're all the same type of atom. Same atom. And remember, more than 1 atom bonded together is so basically an atom bonded to another atom, and like more than that, is going to be a molecule. And this does fit the description. So this is what we're going to call a molecular element. Is it an atom alone? No, it's not, because it has 3 atoms, so it's not just 1 atom. Is it a hydrogen bond? Remember our electron hydrogen bonding? Nope, it's not that. There's no hydrogens. Is it a photon? No, it's not. So yeah, ozone is another example of a molecular element. Free response. Chlorine gas is an irritant that has a strong odor with formula Cl2 and then gas. That little G there means gas. Show the atom, molecule, and matter of the chlorine gas, right? Form of chlorine gas. Atoms can be depicted as a circle but make sure to label it so we know what kind of atom it is. Hint, chlorine forms one bond. Write your answer down in this format. Okay, so the basic idea here is to draw a simple depiction of a chlorine gas atom using the arrows to show that atoms make up molecules and molecules make up matter, right? So for the atom, we can basically just draw a circle with Cl written inside it to represent a chlorine atom. For the molecule, we can just draw two chlorine atoms bonded together by a covalent bond. So for matter, you can just basically just draw a gas cloud, but label what type of gas it is, and many chlorine molecules floating in space, or simply just Cl2 gas. So to represent chlorine and its gaseous state of matter, so all in all, this is what I would write. So this is a chlorine atom. We can just, like the question said, atoms can be depicted as a circle, but make sure to label it so we know what kind of atom it is. So this is a chlorine atom. And we're gonna have to draw the arrow, and the molecule, like I said, two chlorine atoms bonded together. And matter, you can either just do the Cl2 gas, or you can do like a cloud of gas, but make sure you label what's inside. So yeah. So that way we can represent its gaseous state of matter. Let's go down to number 2. Okay. This is benzene, an organic molecule which is liquid at room temperature. Write your answers to the questions. So A, how many different elements do you see? We went over this again in the previous question. And look at it, it's only made out of C's and H's. So how many different elements is that? That's 2. How many total atoms do you see? So as we're just gonna have to do some counting, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So 2 different elements, which is carbon and hydrogen, and 12 total atoms, 6 carbons and 6 hydrogens. Carbon dioxide, CO2, is produced during cellular respiration. If you remove one oxygen atom from carbon dioxide, would you expect the product to have the same chemical and physical properties as CO2? What will be the product? Okay, so I think this question might be a little challenging if you don't know that much chemistry, because I don't think I actually went over this in the lectures. So that is partially my fault, but that's okay. So the answer will be, I'm just going to tell you the answer. I'm not going to write it down just for the sake of time. So the answer is no. The product will not have the same chemical and physical properties as carbon dioxide. Since we remove an oxygen atom, the molecular weight will change and be lower in the product than in carbon dioxide due to its removed oxygen. We exhale carbon dioxide, but the product from removing an oxygen atom is toxic. The product is called carbon monoxide, and that's going to be the formula for carbon monoxide. So I wouldn't expect you to know that if you're only going based on the lectures, but that's just the whole gist of it. Again, if you have questions, please just let me know. Number 4, describe, I think that's the last one, yep. Describe the relationship of an atom and an element. So basically what I want you to take away is that, I'm not going to write the answer, I'm just going to say it. So an atom is the smallest form of an element. Atoms will contain the same properties of the element it composes. So that's the whole gist of what I'm just going to tell you, like what I want you to know. So that concludes the answers for the worksheet that I made. And again, if you have any questions, you need